Okay, let's go over the radical sheet here. First of all, let's determine the domain. Well, this says square root, and you can't take the square root of negative numbers, but you can of 0, so it's from 0 to infinity. Now, you can take the cube root of positive and negative numbers, so that's from negative infinity to infinity. And again, you don't do solid brackets on infinity. Here you're including 0. You can't get to infinity, so it's not included. This is an even root. This is the fourth root. And so you can't do even roots of negatives. And on the fifth root, that's odd, so you can do from negative infinity to infinity. And so if it's even, the domain is from 0 to infinity. And if it's odd, it's from negative infinity to infinity. Square root of 17, if I pull out my calculator, and I can just type that in and get a decimal approximation on it. Square root of 17 is 4.123. Approximately 4.123. This also means square root. You can type in 17 to the 1/2, and it gives you the same answer, or you can type it in 17 to the 0.5, get the same answer, 4.123. 4.123. That's the point of this. That line was that there's several ways to write square root. What times itself 3 times to make -8? That would be -2. This asks the same question. The answer is -2. This does not ask. That's not 1/3. That's 3/10. So -8 to the 3/10. Tenths is an even root, and you can't take an even root of a negative. If I type that into my calculator, parenthesis -8, close parenthesis, to the 0.3, it has to give me i's. Now, if my mode was not in complex, but real numbers there, so I can quit, and I tried to do it, it would say no real answers. The answers are non-real, so couldn't do it. Okay? So, this one is undefined in the reals. Okay. -1 squared, written this way in the calculator, or otherwise it says -1 times -1, which is 1. But this, if you type it in the calculator, will give you -1, because it's saying the negative of 1 squared. That's how that's read by the calculator and by a good mathematician, and so that's still -1. And this says the 0.2, you would think it would be an even power, but it's 0.2 is 1/5. It's an odd power, and so it's you can do this. It's -1. -1. Oh, it's not -1. Let's see here. Let's go. I can quit. We should be able to do parenthesis -1 to the 0.2, and the answer is -1. Okay. Now this one, -27 is -3 times -3 times -3, and if I were to square that, I'm going to have another set of -3 times -3 times -3, and if I'm taking them out in groups of 3, that would be a -3, a -3. If I multiply those, I get 9. Now this says find the cube root of -27, but -27 is -3 times -3 times -3, so the cube root is -3, and if I square that, I get 9. So I can put the square inside or outside. I get the same answer. And this is saying the same thing. Find the cube root and square it. And I can square first and then take the cube root, or I can take the cube root and then square it. I'm going to get 9. These are 3 different ways of writing the same thing. And that was the point of that one. 8 is 3 2's, so the cube root would be a 2. The cube root of x to the third is x. No absolute value needed on odd roots. And y to the fifth, there's 3 y's, so it'll come out as a y, and there'll still be 2 left in the cube root. This says the cube root of the same thing. So it's 2x, y, and then y to the 2/3 is another way to write that. And this, when there's addition, you can't distribute the thirds, and so you can't do anything. It's simplified already. Okay. This page. The square root of 20. Well, 20 is 4 times 5, and the square root of 4 is 2, and we'd still have 5 to the 1/2, or square root of 5. We'd have x, the square root of, well, that means take out in pairs, so there'd be a single coming out, and when there's a single under an even root, you have to do absolute value. There'd still be an x to the 1/2, and this would be, there's 4 y's, and we're taken out in pairs, so there'd be y squared. When it's squared, you don't need the absolute values. This is the same problem, square root, so it's the same answer, except I probably would write the 5 under the square root and have an absolute value of x, and an x under the square root, and a y squared. And here we have subtraction, so I can't distribute, so this is already simplified. Can't do anything to it. This one, this is 12 times 12, and 12 is 4 times 3. So 4 is 2 times 2 times 3 times 2 times 2 times 3, and x 5 times, and y 8 times. So I can take out groups of 4, so there's 4 2's, which is a 2. There's 2 3's left, so that'll stay under the 4th root as a 9, or 3 times 3. There's 4 x's. It's an even root, so it'll be absolute value of x. There'll be 1 left, and 2 groups of 4 y's, so that becomes y squared on the outside. Don't need absolute value because it's squared. Now we're doing this to the third. So this is the same inside, so it would be this to the third power. So I'd have 2 to the third, 8. Absolute value of x to the third would be absolute value of x to the third. Or you could put the 3 on the outside, doesn't matter. Y squared to the third would be y to the 6th. This is what's a little bit different here. Now I've got this 3 times, so I got the 4th root of 9x times 9x times 9x. 3 times. But 9 is 3, 3. So there's a group of 4 3's, so I can take out another 3. So I can write that as 24, but I'll write 3 times 8. And I'll have 2 3's left, so I'll still have a 4th root of 9 and x 3 times x to the third. So 24, absolute value of x to the third, y to the sixth, fourth root of 9x to the third. And this one, fourth root, cubed, but it's got addition. Already simplified.